Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're taking a look at something that I never thought I would have down here in the basement. What I have on the bench is an Archimedes 420/1. Yes, this is a computer made by Acorn, and this computer, when it came out, had an 8 MHz ARM2 RISC processor. ARM as in Acorn RISC machine. Yes, all the things we're using today, like our smartphones and probably my camera, all came from, well, these early ARM processors that Acorn developed. Other than for very brief moments, I've never personally played around with any Archimedes machines. I've seen a few of them that were imported into the US and I played around with them just briefly, but that was it. And I always thought that they were a very interesting part of computing history that I would love to somehow own one day. But I never really thought I would because they're expensive and also really hard to get into the US, especially nowadays. Well, this one was donated to the channel by viewer Mike, who has donated a bunch of other awesome Olivetti European-only stuff to the channel before. Well, Mike somehow got one of these and brought it back and then sent it to me. So what we're gonna do next is we're gonna jump back in time before I open the box with all of this stuff. You're gonna watch me unbox it. And then after that, we'll jump back into real time where I'll start to take a look at this machine and hopefully get it fired up and working. So without further ado, let's get right to it. All right, so this is the package I got from Mike, and it's been sitting around here in the basement for a little while. And this kind of gives away, if I get the glare off of this, what might be inside this box. Now I have opened the top, but I haven't actually looked inside because it's very well packed. That is the Acorn logo, by the way. Acorn, the company that made the BBC Micro, that made ARM processors, because of course the Archimedes was their next computer after their 8-bit line of machines. And well, all our smartphones use ARM processors now, and Macintoshes, and all sorts of things in the world. Billions and billions of devices run ARM processors that do all stem from Acorn's original designs. So I'm very curious to see what's in here. This box has been down in the basement, as I think I said already, for a while now. So we have a note. The note reads, "Hi Adrian, Mike C here. No Olivetti PC1 in the box, don't worry." So yes, Mike has gone ahead and sent in a bunch of Olivetti stuff already, including a couple PC1 computers, which have yet to really make their way onto the main channel. They've been on the second channel. This time I'm sending something for your Acorn collection, a rare Archimedes, at least here in the US. I've always been intrigued by the Archimedes' role in computing history, and I finally found a good one in the UK. Okay, I'm blown away. Sahad, the seller, is a viewer of yours and was thrilled to hear that his old computer was heading to the basement. That's amazing. This machine is an Archimedes 420/1, which came out in 1989. Originally, it came with an ARM2 processor, which is a VL2333, 8 megahertz, made by VLSI. Yes, Acorn didn't have their own fab or anything. It wasn't like Commodore with MOS. So they contracted with VLSI to make these original ARM chips. 8 freaking megahertz. But you know what? Even at that speed, same as like the Amiga with the 68,000, this thing would blow the doors off the original Amiga, as far as I'm aware. 2 megs of RAM, 20 meg hard drive. This one, however, has been beefed up a bit. The CPU now runs at 25 megahertz ARM3 mounted on a Watford Electronics board that plugs into the original socket. Says RAM's been bumped up to 4 megabytes and the original hard drive has been replaced by a 1 gig IDE flash memory drive. It's running RiscOS 3 instead of the original RiscOS 2, and no original Acorn mouse, unfortunately, but in the box you'll find a USB mouse adapter and a generic optical mouse. Because of the shape, the adapter doesn't fit flush behind the keyboard, but Sahad said it works fine. This here is my flabbergasted face. I figured as much that there was an Acorn Archimedes in the box, but an upgraded one. And one of the things about these Archimedes machines that I, thought was pretty much the same on all of them is that the batteries, it has a NiCad battery for storage of settings and clock and whatever, and it leaks and it totally damages the board. So a lot of these Archimedes machines require a lot of TLC because of the extensive damage that's happened to the main board. I'm completely blown away by this, and especially with the fact that here in the United States, where I happen to live right now, well, due to recent stuff happening, I'm not going to talk about all the details, but it's, just to say it's really hard to get packages internationally now. So the fact that Mike sent this to me, and Mike lives in Texas, so Mike was able to get this to the US, and I think I've actually had this machine now for enough time that it might have been before the change happened, but Mike might go on, this might be a second page here, to talk about how this actually entered the country, because it seems that Mike found this from a UK seller, Sahad, as I mentioned, and Mike's Italian, so maybe Mike was visiting family in Italy and then picked it up and brought it back with him on the plane or something. I'm not exactly sure, but either way, I kind of figured that I would never end up getting an Archimedes machine here in North America unless I picked it up personally over in Europe or someone else brought it into the United States for me. Right, so page 2 says, I'm including a 3-button Logitech bus mouse, quadrature encoding, that I got at VCF Southwest. So yes, I did meet Mike at the VCF in Dallas. I will include a picture right here. It's really awesome to meet Mike. He sent so much stuff into the channel, so that's pretty amazing. It's the same case as the Acorn mice and the same mini DIN 9 connector. However, it needs to be rewired for the proprietary Acorn pinout in case you want to recreate the perfect era-appropriate Archimedes setup. I haven't had a chance to test it here in the US because of the 240 volt PSU, but as far as I know, everything should be in proper working condition. A couple of slot cover screws are missing in the back, and a few final notes. In the box, you'll also find a Commodore 1084 to Acorn AKF12 monitor conversion kit. I'm under the impression that the boxy Philips 1084 that I've made a bunch of videos about was sold under Acorn branding, so same Philips monitor, but electrically slightly different. So there's a conversion kit. I just figured this thing connects to the back with SCART, which I've already modded my 1084 for SCART duty. Mike's included also a t-shirt. Thank you very much. I always need more t-shirts. Check this webpage, and there's a webpage here for all the Archimedes information you will need. No stupid tariffs were paid in the import of this computer. Okay, so that's what I was just talking about. The custom chips in this machine have charming names: Anna, Albion, Arabella. I love it. Very much like the Commodore Amiga and that chipset. In fact, when I went to VCF Midwest just recently, I was lucky enough to finally see with my own eyes the original Amiga prototype. The one, as far as I'm aware, was brought to CES to show off the Amiga's capabilities all the way back before the Amiga launched, the Amiga 1000 launched. And I'll put a picture up now, but it's just like a stack of boards hooked up together. It's all prototyped, it's wire wrapped. Who knows how any of that could have worked. But a whole bunch of the custom chips were designed and running in TTL and maybe with PAL chips and things like that. All wire wrapped together, all proto-boarded together, and then hooked up to like a main motherboard that was also a prototype board with 68,000 and stuff. Totally wild to see all that. I'll let you take it all from here. Live long and prosper, Mike. Wow, Mike. Well, thank you very much. Let's unpack the rest of this box because I am blown away, totally blown away here. Okay, so everything was very nicely packed here. Let's see. So mice and adapter, maybe I'll just sort of pull all the smaller stuff out first. This looks like the keyboard, which don't know if the keyboard is proprietary. I assume it is. Now, interesting is they made a wedge version of this. Maybe it was called the 3000. I can't remember. It looks like the Amiga 500, but it's got some cool colored keys on it and stuff like that. Obviously, this is a desktop computer of some kind with a separate keyboard, so more like an Amiga 3000 or 2000 or something like that. Wow. Okay, look at this, an Archimedes shirt. Oh, Mike. Mike literally thinks of everything. Literally everything. Oh, we'll look at that in a second. I said I was pulling everything out of the box. This is incredible. So this got shipped to me here in Portland, of course, from Texas. And that's why Mike so lovingly packed this up, just to make sure that its trip all the way from the UK to the US and then to me would make sure the computer got here totally unscathed. And there it is. Wow, wow. So freaking cool. I don't think I've ever seen one of these particular ones. And on the back of it, I should probably reposition the camera because this is so awkward. Well, there's the back. These are those slot covers that have a few missing screws. They are here though. That means I just need to find the right screws. Let me get resituated here. So this is it, the Archimedes 420/1. So the Archimedes 400 series was the first line of these computers that was released by Acorn, with the 20 designating that this had a 20 megabyte hard drive. I thought for a second that maybe there was room for a second floppy disk, but it doesn't look like this is actually a removable cover. So if there was a dual floppy cheaper model, probably was a different faceplate. It's under the floppy drive where the keyboard connects up to the computer, and looking at the keyboard edge on, this is where the mouse connects up to, and the reset button for the entire computer is right there. Looking at the pinout of the keyboard connector actually looks to be the same as PS2. I think it is at least. And this looks like a bus mouse connector, which coincides with what Mike said in the letter, that a regular Logitech bus mouse uses the same connector, but a different pinout. Thanks for that, Acorn. The keyboard layout on the Archimedes, at least this first version, is decidedly North American, if I don't say so myself. Shift 4 is a $, and pound symbols over here next to the backspace key. I suppose the only thing that's slightly different than, say, a Model M is that the control key is where caps lock is. Caps lock is down here. And it is not a latching key, it's electronically latched. Now, people watching this who are more familiar with Acorns are going to need to chime in, and if these labels have yellowed, I don't think the keyboard is really yellowed. This thing seems, if it has, just ever so slightly, but the labels are oddly yellow. Comparing to the computer though, the Archimedes label on the computer is a little bit less yellow, so I guess that means maybe the keyboard one has yellowed slightly. The build quality of the Archimedes seems, on the surface at least, really nice. The keyboard is a good solid plastic keyboard, but the machine itself is all metal except for this front part, which is plastic. Looks like there's just a little bit of rust on the edge of the case, although this could have been the computer just propped up on its side on a shelf at some point, because there's a little bit of paint transfer into the case texture, and that might be what that is as well. The other side of the case looks exactly like the one we just looked at. There's no buttons or ports or anything like that on the sides of the computer. On the back, we have these two expansion slots, which are the ones that were missing those screws. We have a monochrome composite output along with a sync output. My assumption is the composite sync output would be used for external Genlock hardware connected to the analog RGB output. 9-pin serial, headphone jack, 32 ohms impedance, parallel port, Econet or Econet networking jack. This was a networking standard that Acorn came up with, and a lot of their APA computers also had Econet ports on them that allowed you to very simply and easily connect up a bunch of these together in a classroom and have, say, a BBC Master 128 operating as a file server for the rest of the machines. Pretty ingenious and pretty ahead of its time. Not that unlike Apple's AppleTalk network that was popular on those original Macs. But if I have my history right, the Econet standard predates AppleTalk. So if anything, Apple maybe borrowed from Acorn's design with the networking stuff. And finally, we have our power supply, which I'm going to have to modify for operation on 120 volts. Should be no problem. I haven't looked into this or done any research yet. But if it's anything like Acorn's other power supplies, like on the BBC Master, it was designed with the ability to run 120 volts already built into the design. So it's a relatively simple mod to get that working. Here is the awesome Archimedes shirt that Mike has gone ahead and sent along. Large size, thank you very much. That is perfect. I won't be wearing it in this video until I wash the shirt, but it'll definitely be seen in future videos. Let's take a look at these two boxes that Mike has sent along. The first mouse is the Kensington optical mouse that has a sticky rubber syndrome on the sides, USB. This must be the little adapter that goes from that bus mouse connector port to USB. Oh, wow. That's slim and pretty cool. It's got a little dent in the connector there. Is the part number rubbed off on that microcontroller? That's funny. But there it is, ArcMouse USB by TrueMouse.com if you want to pick one of these up yourself. It's pretty low profile because they took the extra parts off this connector, so it should be a relatively flush. But I suppose one of the issues is this USB connector is big enough that it sticks out quite a bit out of the back of the keyboard. Now, sometimes one of the problems with these adapters, and I have one that is actually designed for the Commodore Amiga, is that even though they have USB ports, they don't really use a USB protocol, and they rely on older mice that actually have a USB connector, but can fall back to the PS2 protocol to work. And I don't know if this one works that way, but my Amiga one certainly does. So you can't just take any USB mouse, like say a wireless mouse with a little dongle, plug it into that and have it work. So because of that, I keep this Microsoft mouse off to the side because it says right on here, USB and PS2 compatible. And this absolutely does work with the Amiga adapter. And if this one works the same, then this will be a nicer alternative to the sticky mouse here. Now, Mike went over and above and actually found one of the Logitech mice that looks exactly like the original Archimedes mice, and even has the little holder. And the photo of the Archimedes on Wikipedia has this stuck on top of the monitor. I don't know if this is a Logitech part, doesn't say anything on here, but the mouse certainly fits in there very nicely. So I'm assuming this is actually made for the Logitech mice. These were very common in that they were prolific on all sorts of different computers. In fact, I'm pretty positive Mike went and sent one of these mice along with the Olivetti PC-1 because it also uses a bus mouse, and the Olivetti mouse that was bundled with those computers was actually the same styling as this. It just probably said Olivetti on it. And I think the one Mike sent me, it says something else on there, but they're all relatively interchangeable. And as Mike mentioned, all I have to do is rewire this one, and then I can just use it directly without any kind of adapter like this. Although it's a ball mouse, and using an optical mouse like this Microsoft mouse would just be a whole lot more enjoyable. But of course, this is more period correct, and I kind of like that actually. Okay, and the last thing that Mike sent along is this, which I'm super curious about. The Commodore 1084 to Acorn AKF 12 monitor conversion kit from color to color. Yeah, warning, high voltage. Yes, do not open unless you know what you're doing. Let's see what's in here. Well, there's no electronics in here. Ah, look at this. A new front door for the Commodore 1084 monitor. Now this must be a replica, but I think it looks really good if it is a replica. Yeah, I can see that this is actually 3D printed. And you can download these STL files pretty easily. This one's a really, really nice print though. I've actually had to replace the doors on, I think, all of my 1084s because they were all missing. I happen to have used just like out of a clear PLA because I think it looks kind of fun. But ultimately, this one looks pretty cool though. Very, very authentic looking. And I've seen photographs of the Acorn monitor and yeah, it looks really good. And besides the front door, if we look inside, looks like Retro 8-Bit Shop has a replacement Acorn label as well. So on the monitor, it will say, I think, 1084 or 1084S. So I just have to peel that off, and I can stick on this Acorn replica to turn my monitor into what looks like the real deal. Now, as far as I'm aware, because I talked to Mark over the Retro channel about the actual Acorn monitor, and it's got some oddities to it in that it's got a SCART jack on the back, but I think it's missing the video inputs entirely. So it only has SCART. It's maybe missing the RGB jacks as well. It's kind of a limited monitor. And these were choices that Acorn could make when they contracted Philips to make the monitor for them. Now, besides the lack of connectors on the back, it's functionally identical. The monitor performs exactly the same as the Commodore 1084. And in fact, well, my 1084 that's sitting over there is the one that I did a SCART mod on. So if I had a SCART cable that went from the RGB jack on this to the SCART actual connector, it would just work on that monitor. But I don't, so I'm just gonna have to make a cable that goes from the 9-pin connector on the back of this to the DIN jack that's used on the 1084. All right, so the question is, what should I do next? I think the next logical thing to do with this machine is, before turning it on, let's take it apart. Well, maybe not take it apart fully, but at least take a look inside, especially because of the fact that this thing has traveled around the world, and we don't know if like there are cards and stuff that have come loose, because we know, for instance, that the CPU has been expanded, it's on a card. So first thing I need to do is get these back covers off because they're missing screws. It looks like they were hot glued on, and I don't know if these are even original or maybe replicas because there's a bunch of extra paint on there. So my assumption is these are actually replicas. All right, the fasteners are all out. And now I have to figure out how to get the case apart. I think it slides back towards me. Oh, there we go. It's slid backwards a little bit. All right, well, that was firmly attached. Ooh. That's the inside. This is my first time ever looking inside one of these. All right, well, first off, definitely we've had some battery leakage in the past. There is There are signs of that all over the place, like all over the power supply, and we have some replacement batteries there, and that was rust, I guess, on the outside of the machine, probably from leaking alkaline batteries. And you can see some of it down there as well. Nice that the battery wasn't actually mounted on the PCB, therefore the leakage affected the case, which is solid metal, not a big deal, not so much the motherboard. Although that Econet connector is looking quite crusty there. You can see some of the corrosion there on the case bottom. Not a big deal, but I suppose at some point in the future, if I fully disassemble this, I can give the machine a little bit of TLC to try to clean that up a little bit. So trying to get a little bit of a lay of the land, we have our floppy drive. It looks like a rather standard Sugart style connector. There is a second power connector, which would imply a second floppy drive is possible. But my assumption, because there's an extra Molex power connector here, is that there was the 20 megabyte, 3.5-inch hard drive there originally. You can see some witness marks on there where maybe there was a bracket that held it on. And actually take a look at that. My assumption is it was an MFM or SD506 type drive connected up through that connector there. So yeah, 3.5-inch drive. But then this obviously is our IDE adapter right there, Acorn IDE. Looks like it supports a CH376 USB module as well. If anyone knows what the USB would be used for, comment down below, but this is a pretty modern thing, look, 2025 here. So this was obviously added before this was sent to me. And we have a 1 gigabyte IDE flash module on here, but it looks like we do have a normal IDE connector if you would like to hook up a standard hard drive. You can get a glimpse that this thing has 4 expansion slots. So there's one below the IDE module, and then we have 2 other expansion slots right here. The expansion slots are just held on this riser card, which is firmly attached, which is great. So for shipping, nothing came loose. That was slightly loose. I'll just give that a little push so it's back in place. But actually underneath the IDE module, which I'll just pop off, there's some kind of a small module that's connected to the board here. This looks like it's connected through a 4-pin connector, and there's a crystal oscillator on the bottom, a small IC, and a cable that goes to that connector there, which looks like it says aux.io. This is the battery connector, so it's not exactly that, but I don't know what aux.io is. And then this connector here looks like it goes to the speaker on the front of the case, plus some LEDs. And then this connector here goes to the cooling fan. You'll notice the power supply connects up to, say, this riser board using these types of connectors. That's very standard for what Acorn was doing. They did that on the BBC Micro as well, and the Master as well is hooked up that way. It's just a different way of doing it. In fact, you could just make out down below this bracket, the connection to the motherboard is also hooked up to the power supply in a similar fashion. Which is actually good, because if you do need to replace this, it's quite trivial to connect up to these connectors. So you could use a Pico ATX, for instance, to replace this entire power supply. We do have a date code, 48th week of 1988 on the power supply. And right here, Acorn Universal Board with a 1989 date code on it, at least on the silkscreen markings, which coincides with some of the markings on the ICs. That one is 1989. This one's 89 6th week, where the VLSI chip itself is 41st week of 1988. As far as I'm aware from my reading though, this machine was released in 1987, and I'm assuming that the processor is right there. So that's that upgrade board that was mentioned in the letter. 1991, 21st week, the 86C020 ARM processor. And it has a 50 megahertz crystal oscillator on board, which probably implies this runs at 25 megahertz versus the original 8 megahertz of the original ARM processor. And indeed, there it is. CPU is now 25 megahertz ARM3 mounted to a Watford Electronics board that plugs in the original socket. I think the original chip would have looked like one of these, so it has a PLC-C type socket in there. Let's see if this is in the socket well. Yeah, that's in there really quite well. So it didn't get dislodged from shipping. Part of me is slightly sad that it doesn't have the original 8 megahertz chip, and it wasn't included as far as I'm aware. Pretty sure that completely replaces the original processor. So there's really no way for me to experience what this machine was like at its original 8 megahertz speed, which I'd kind of like to do ultimately, because for instance, the original Amiga 500 and the Amiga 2000 that I had ran at around 7 point something megahertz with the Motorola 68000 processor, as did the Atari ST and the Macintosh. And it would be kind of cool to know how much faster the ARM processor at the same or similar 8 megahertz was to the 68000, which was so super common at the time. From the look of the accelerator that's in this machine, it's definitely period correct. So when this machine was used back in that time, the original processor was taken out and discarded probably. And I assume finding those VLSI ARM processors, the ARM2 processor that was in this originally, is basically impossible at this point. I know there's going to be people out there watching who are like, why is he talking about slowing down the computer to 8 megahertz? But part of me is fascinated by the fact that the ARM2 chip that was in here was so ahead of its time and so much faster than, well, pretty much all the other contemporary home computers, that's why I'd like to kind of see it running at that speed. And it looks like on this machine, the RAM is, where is the RAM? I just catch a tiny glimpse of it. It's right there down on the motherboard. It's zip packaging. They're little packages that stand up on end. And the letter says it was upgraded from 2 to 4 megabytes. I don't see a RAM board in here, so there must have been extra zip sockets, maybe under the drive cage there on the front edge of the motherboard. I am completely and utterly a noob at this machine, so please excuse my constant babbling and not knowing how this thing works, because, well, that's how it goes. I'm exploring this thing with you together. So this is really my first time ever looking inside one of these, and it's pretty darn cool. Now, one thing that's kind of curious to me is this expansion header here that's unpopulated. If I'm correct, on a lot of the other Acorn machines, there's a pin header there as well, I swear that that might be the Econet Module. So that gives this thing the networking capability, and since that's missing, this thing might not actually have Econet. Now, one thing I didn't look at is the bottom of the machine, and there we go. We have a label, and it says designed and manufactured in the UK by Acorn Computers in Cambridge, England, 1987. And there's our serial number sticker for anyone who's interested in that. All right, before I attempt to turn this thing on, let's take a look at some of the history of Acorn, just briefly, and this Archimedes machine. And let me just preface this by saying the history of Acorn is a lot more complicated than I'm going to present here. I'm just going to skim over some of the stuff in here. But if you want to know more about this, I'm sure there are some really good documentaries about Acorn. Plus, these articles are available for you to peruse at your leisure. So Acorn was a Cambridge, UK company founded in 1978 and was most famous for this machine right here, the BBC Micro. And originally, their first computer, well, first sort of home computer, was the Acorn Atom. This came out in 1980. And it was in kit form or assembled, and it was a little all-in-one computer. It was a 1 megahertz 6502, a 2K of RAM, expandable to 12, had color graphics, it supported one-channel beep speaker sound, it had cassette and floppy drive interface, and the Atom included Acorn System Basic, which was developed by Sophie Wilson, and was known to be very fast, and included a lot of the awesome features that BBC Basic was to be known for, which was the subsequent follow-up to this machine. Acorn struck a deal with the BBC, or the British Broadcasting Corporation, and this machine was created. Essentially, it was a reworked version of the Atom, as far as I'm aware, and it was released in 1981, and it was known to be relatively expensive, 335 pounds for the Model B in 1981. I don't know what that exactly converts to, but I think compared to competitor computers on the market, this was quite costly, but it was extremely capable, and because BBC was working with all the schools within the UK, this machine was deployed all over the country in schools, so a lot of kids used this machine as the very first computer they ever used. The architecture of the BBC Micro was an evolution of the Atom, 2 megahertz 6502, more RAM, more ROM, more capabilities, much more expandable, better graphics, better sound, and it also featured BBC Basic, which I think it would be hard to argue otherwise, that this is the best BASIC for 8-bit computers that ever existed. And I'll leave it to people watching to extol the virtues of BBC Basic down in the comment section, but I've really learned a lot about it over the years, and I've realized how incredibly powerful it is compared to all the other dialects of BASIC. And yeah, it all kind of got its start on the BBC Micro thanks to Sophie Wilson. Now, while the BBC Micro sold for a number of years, because it was relatively expensive, as I mentioned, compared to something like the ZX Spectrum, and I think even the Commodore 64 as that came in down in price, Acorn released the Acorn Electron, which is actually a machine that I featured on the channel before. I think I did a repair of this and I swapped out the power supply inside. It was released at a cheaper price soon after the BBC Micro came out, and while this machine runs at 2 megahertz and has BBC Basic and has roughly the same graphics capability as the BBC Micro, one of the biggest Achilles heel of the machine is its slow performance, and that was due to the fact that it was only using 4 bits of memory. So it had 32K of RAM and it used 64K by 1 DRAMs, but it only had 4 of them. So the chipset inside the computer had to do a bunch of work trying to, well, turn a 4-bit memory bus into an 8-bit bus that the CPU could use, which really slowed down the computer. Effectively, even though the Acorn Electron is compatible with the BBC Micro, it's about 1/4 the speed, at least in a lot of operations. As the 80s progressed, companies like Atari, Apple,
Commodore were coming out with 16-bit machines, all supporting the Motorola 68000, and Acorn was working to try to upgrade its computer systems to also the next generation, 16-bit or even beyond. So they started working on looking at different CPUs to figure out which would be a good fit for their architecture, and realized that not a lot of stuff was really a good fit. In fact, the BBC Micro, which is a great development platform because it's so expandable, has a way to have a second CPU, a coprocessor, but it really didn't work well with the Motorola 68000 due to the architecture of that chip. So Acorn decided to try making their own CPU. So after reading white papers by Berkeley on RISC processors, they thought, well, maybe they could do this. And Sophie Wilson actually went ahead and wrote a simulator for, well, the ARM instruction set that ran in BBC Basic on a second 6502 processor, just to sort of prove that it was possible as a proof of concept, and it worked. So by 1987, Acorn had spent £5 million developing this new architecture, and they contracted with VLSI to actually produce the first chip, which was known as the ARM1, and it came out in 1985. Now for the Archimedes itself, we're looking at here as a bunch of other custom chips to make the whole architecture work. This is just the processor alone, but plugged into a BBC Micro on that coprocessor connector, the tube socket it's called, will allow them to really test this thing out. And in fact, using that faster ARM processor, the ARM1 they developed, they were able to, well, create some CAD software to help develop ARM2, the successor to the ARM1, and the one that came out inside this first Archimedes machine. Now, I know I said earlier that the Archimedes was the first commercial use of Acorn's RISC processor, but actually wasn't. It looks like they actually had a development system which they sold for £4,500 to allow you to experience the RISC ARM processor hooked up to a BBC Master system. But that's more of a kind of a niche thing. It wasn't really like something they would sell to normal people. And that brings us to the Archimedes that came out in mid-1987. That was the first commercial use of Acorn's RISC processor, the ARM processor, also known at the time as Acorn RISC machine. Now, it does say here that, well, IBM beat them to market in 1986 with the first RISC technology personal computer. This is it, the IBM RT-PC. Not something I've ever heard of. It used IBM's proprietary ROMP processor, which commercialized technologies pioneered by IBM Research's 801 experimental mini computer. And it appeared typically you could pair it with a high-resolution display and graphics card, I'm sure, for CAD/CAM work, computer-aided design and manufacturing. And it seems that IBM was selling this at very high workstation-y prices of $40,000, at least for the graphics with the monitor and all that stuff. But that obviously was extremely high and really in no way competed with something like the Archimedes, which, you know, obviously we're looking at pounds in 80s dollars, so it's hard to compare that to the US dollars. But I think £799 for the entry-level Archimedes 400 obviously was nowhere near the 40,000 US dollars that IBM was charging like 1 year earlier for their machine. Well, for those of you in North America, if you're watching and you've never heard of the Archimedes, well, there's a reason, because while it was somewhat popular in Australia, Ireland, and the UK, it just really never got a footing outside of those regions, unfortunately, even if it was an incredibly capable machine with a GUI and a fast RISC processor and highly expandable and full 32-bit and all that stuff. And in fact, even when it comes to home users in the UK and the other regions where this machine was popular, really the Atari ST and the Amiga is what people tended to buy. And I'll be looking to hear from folks who made that purchasing decision back in the day. Was the reason to go with Amiga and Atari ST simply because there were games available for it? Or was it cheaper than these Archimedes machines? Because of our launch price of $799 to $2299, obviously that's with, you know, hard drive and monitor and all that stuff for the expensive one, which is £2,800 to $8,200 today. That does seem relatively costly, but computers were just expensive back then. And I'm thinking something like the Amiga 1000 was probably easily just as expensive or more than this. Although potentially by 1987, the Amiga 500 I think was out and the prices were dropping drastically. There were lots of games included with it, and the Atari ST was an even cheaper machine, and there were tons of games for that as well, even if the machines, both of them, were probably a lot less capable than this. In fact, I mean, just look at this. The Archimedes 640 by 256 at 256 colors. The Amiga didn't get 256 colors until the AGA machines like the Amiga 1200 and 4000, and with the Atari ST it was until the Falcon that it got this many colors as well. And look, 8-channel, 8-bit stereo sound as well. I mean, this machine's extremely capable, and it came out just 2 years after the Amiga did, and also 2 years after the Atari ST. Now, the Archimedes line of machines was discontinued in the mid-1990s, and that's kind of where a lot of the 16-bit machines kind of died, except for Apple's, basically. The Macintosh continued on from there and went to PowerPC and whatnot, which ironically is a RISC-based chip. And to be honest, it might have a lineage that descends back to that first IBM RT PC that we just looked at a second ago. But at least with the end of the Archimedes in the mid-90s, it wasn't the end of the line for all the hard work that Sophie Wilson and the other engineers had put into the processor in this thing, because, as I mentioned, ARM processors are essentially everywhere in the entire world at this point. Every single thing from a vape pen to your smoke detector to cameras and phones and computers now and monitors, and pretty much everything has got some ARM core inside of it at some point. And what is ARM Holdings now? I think it's called that, or maybe it has a different name at this point. I can't keep track of the modern stuff, but they no longer develop any hardware. This is just sort of a licensing thing that these cores are developed inside of ARM, and then companies like Apple or whomever buys a license from ARM and then runs with it and, develops extensions and does their own thing with it, and they manufacture their own chips or use fabs to do it. And it's kind of amazing that it all goes back to the first commercial implementation of this chip in this machine. Like, that's just, it still kind of blows my mind. It absolutely blows my mind. And that kind of goes back to why I was saying it would be really cool to experience the ARM2 original 8 megahertz chip that would have been in here versus this much, much faster 25 megahertz ARM3 that this thing has been upgraded with. Now, a small correction. I know I had mentioned that this machine was one of the first ones released. It was actually not. Architecturally, I think it's the same. Looks like the very first model that came out. Well, there were a few different models that came out, but the desktop form factor, like this 420/1, would have been one of these, the 410 or the 440. Looks like the biggest difference between the 440 and the 410 is the faceplate. It has a little bit of a different floppy drive hole there. And actually, it's not 100% clear to me if the 305 and the 310 are also in the same exact form factor as this. It kind of implies that they are. The 305 and the 310 are cheaper with fewer options. Looking at Chris Acorn's website, the A300 came in a couple different variants. Looks like there was a 0.5 meg version, 1 meg version, and a music workstation version, all floppy drive based. And there's a picture of the A310. Yes, absolutely the same form factor as this machine. Looks identical, in fact, other than the front bezel looking different with that floppy drive thing, and no hard drive LED indicator. Another cool thing is, of course, it has these awesome red F keys that the keyboard that came with this machine does not have. And it looks like this Arthur OS, which was before RiscOS came out, and it did have a GUI. So even on launch, this thing looks like it has a GUI. And on the back of the machine, the motherboard obviously is different. It's certainly very similar, but this one has that sync output. Headphone jack is moved over, I think, over there. And the Econet jack, I guess, is just not fitted at all. Internally, it looks like it only has potentially 2 expansion slots versus the 4 that are on this machine. Okay, and the motherboard obviously is significantly different because this thing has that zip memory at the front that this A310 does not have. And you'll notice, here's another photo of a different A310. It's got a bunch of different expansion modules in it. ROM module, looks like maybe a mouse port or something, user port, SCSI port potentially. Oh yeah, it says here, Morley SCSI card. Oh, and there it is. The hard drive is actually mounted in that second drive bay and hooked up to the expansion card. And this has a 4-port expansion card in it, which is just like the one in this machine. In fact, the power supply looks identical as well. This looks like exactly the same power supply. Looking at the A400 series, I realize now, and I should have realized this a moment ago, that the second digit of the model number has to do with the RAM size, because this one is a 420, and I think it had 2 megabytes of memory. And we had the 410 and the 440. So people probably been screaming at your screen the whole time watching this. That has nothing to do with the hard drive, and it has to do entirely with the RAM size. The original 440 launched also alongside the 330. It says it was similar, although it had different motherboard with a built-in hard drive controller, which absolutely is what's on this machine here. Came with 20 meg hard drive, unlike the A300. A440 was not a BBC microcomputer, so its keyboard did not have the red function keys and the BBC logo. So that explains the lack of the red keys. Curious. Right, looking at the back of the machine, the motherboard again is not exactly the same because I can see that the headphone jack is there, and looking at this machine, it's there. But we have the 4 expansion slots. There is the 20 meg hard drive. Here's a photo of the motherboard. So yes, absolutely, this version that we have here, the /1, has that zip memory as opposed to these DIP chips at the front. And there's the same ST506 hard drive interface, MFM hard drive interface that we have on this machine. By the way, the reason why there's 2 connectors there is for drive A or drive 1 and drive 2. And here we are at the 400/1, which is absolutely what this machine is. It looks like it's just a revised version of the old A4XO range, but it has a new memory controller, which gives you a slight performance improvement over the older systems. And as I mentioned, I was wrong about the hard drive size. So the 410 is 1 meg of RAM, 420 is 2 megs of RAM, and it's a 2 meg version that gets the hard drive. And the 440 existed as well, /1, that had 4 megs with a 50 megabyte hard drive and 1 floppy drive. In fact, there are the different versions. And there it is. Interesting is they were no longer using the Philips monitor that was in use on the older ones. I wonder if there's a 31 kilohertz monitor. I actually don't even know if these machines can do a 31 kilohertz video display mode, but you can see RiscOS 2 running on the system there. And yeah, there's our exact thing. I guess I'm missing this little clear cover on the keyboard. I think there were templates you could stick in there and it was flip up. There's that mouse, which looks just like the one that Mike sent. And look, she's really doing some desktop publishing, getting down to work with her laser printer and, color graphs and stuff like that on our Archimedes 410/1. Here's a little blurb on the 420/1 that we have right here. And yes, like as we said, 20 meg hard drive, 2 megs of RAM. That's what it originally came with. Obviously, it supported 4 megs of RAM, probably on the motherboard. So my assumption is those zip chips that upgrade this thing have been installed at some point in the past, which is why it's got 4 megs of RAM now. Now, when it comes to the graphics and the display output of this thing and talks about the monitors here, we have to think about, 1987 when this came out, most people using PCs were probably still on CGA, maybe EGA. VGA had just come out, but it would have been incredibly expensive and really rare in the market. This thing had 640 by 256, so just basically 15 kilohertz video, so normal PAL, and it would have been at 50 hertz, so rather flickery. But I think 256 colors with 4096 color palette. But it does say here that it had high resolution multi-scan monitor, so I'm assuming 31 kilohertz, so it was like 640 by 480, 60 hertz maybe. Ultra high res monochrome as well, and low cost composite video. And of course, you didn't need graphics cards. It was all just sort of built into this thing. Of course, using these higher resolution modes would take away from your system memory since it didn't have a video card. But it really looks like the graphics capabilities of this thing are kind of mind blowing for a computer in its class, at least. There was a software PC emulator available for the Archimedes. I will definitely want to try that out. MS-DOS 3.21. I really wonder how fast it is, but the fact that the graphics are so capable on this means it could easily emulate CGA graphics and have no issues with that. And while you could do a similar thing on an Amiga with a stock 68,000, it was slow. It was very slow. And the original 8 megahertz processor was rated at 4 MIPS, which I don't really know how that compares to other things, but I'm assuming very fast. A bunch of stuff from the BBC Micro was carried forward, like ADFS, that's the disk file system. So I think it's pretty much compatible. Like you could potentially put a disk from a BBC Micro, a 3.5-inch one, into this, and it would be able to read it. The Acorn Archimedes was running BBC Basic as well. So while it had a full GUI, it also had BBC Basic, and that meant it was backwards compatible with all those programs written for those earlier machines, even though from an architecture standpoint, it's totally different. And I think anything that was using 6502 assembly language in line with the Basic, I don't think would work. Although maybe it could convert that stuff on the fly. I'm sure people who are more familiar with this machine could probably comment on that down below. Actually, it says here, included with this machine is a 6502 emulator. So maybe it did run all the stuff for the BBC Micro. Amazing, absolutely amazing. And it looks like the service manual is available for this machine, which is fantastic in case I have to do any repairs for it. And here we are, the back of the 410/1. So yes, that's exactly the same as this. Although, oddly enough, it says Econet not fitted, and it looks like that's not a sticker, that's like metal there, but this thing has the the DINC jack fitted. This obviously has one expansion connector and the original blanking plates. And scrolling down further, we have a full picture of the motherboard, and this is definitely the motherboard that's in this machine. And we can see there's 2 rows of these zip ICs, and there would have been 16 for the 2 megabyte configuration and an additional 16 that would have been installed for the 4 megabytes that this thing has been upgraded to. And as for the OS itself, it looks like it's contained on ROM. So these are the 4 ICs that are there. And of course, they're on this machine as well. This thing has the upgrade as well. And the 4 megabytes of RAM above the ARM2 and the MC1A. That's the memory controller that's been upgraded on this machine, the /1, to give that better performance. That's this chip here. There's the original CPU that has been replaced in this machine. Now, I forgot about this, but I read this once before, that the expansion slots that are available on this, and there are 4, and the IDE interfaces in one of them are called modules. And lastly, before we actually get to testing this machine, sorry, I haven't been going on for a while, but this is so fascinating. The A3000 was launched alongside these 420/1s and 410/1s, and it was the wedge computer. The assumption is this was probably a lower cost machine aimed more at the home market versus these desktop computers. And obviously this success of the Amiga 500 and the Atari ST probably spurred on this particular form factor. And it says here, yeah, it was designed to be the cheap computer with limited expansion and a combined keyboard and system unit. So probably did away with these modules, or maybe most of them. It looks like they omitted the RS-232 port to save money, but I mean, I don't think that really mattered necessarily. And it did have a single external module port, so probably a lot like the Amiga 500 with the expansion connector on the side. No option for a hard drive except as an external SCSI or IDE module. And the A3000 was also the last BBC microcomputer. It had a BBC logo on the keyboard. I really love how this thing looks. That is just freaking cool. The red function keys, or orange, whatever color you want to call them, they look great. And it looks like there were successors, the 310, 320, and the 4000. Let's just jump over to the 4000. What does that look like? Exactly. Oh, that is so boring compared to the wedge computer. I have a soft spot in my heart for the wedges. I really do. And there's the 3020, a little bit more modernized, a little more of a bump in the back there compared to the original one. And I remember seeing pictures of this. This is a 310 with the green keys and a bunch of these colorful pictures on here with like music notes and stuff, you know, learning and all that. And it looked like, just like for this model, there were a whole bunch of expansion modules that were designed for this thing. Ethernet, memory upgrades, digitizers. And just like on the Amiga, the floppy drive was on the side. And looking at the back, there's that expansion connector. So it's on the back with a pin header, probably the exact same connector that's on this machine, which theoretically means you could just use any of these cards, just plug right into there. That's quite cool. Taking a page from Atari ST with the mouse connection on the bottom. Why? Why? That's horrible. I get if you have a limited amount of space on the side of the machine, you don't want this connector sticking out the side, but I struggle to believe it just couldn't have been squeezed in somewhere on the back. But I guess it didn't matter. You plugged it in once and it was fine. All right, and there's the A3000 motherboard, definitely a lot smaller than this, and it looks like they just did away with, say, the PLC-C sockets. That's going to save money. Looks like the power supply is a far cheaper affair, a cardboard covering it. I swear I thought that these have batteries that go bad and cause all sorts of damage, but maybe I'm mistaken. Oh, wait, I just missed it. It's that little thing right there. CMOS RAM battery, bottom left. So does that leak and cause massive destruction on these motherboards? The keyboard must use a memory and connect with these connectors. Ooh, oh joy, oh joy. Right, I've gone on for long enough. I think I need to actually get to turning on this computer. That website is basically an endless sea of information you can just look at forever. Everything you want to know about this machine is there. Absolutely fantastic. That is a great resource that exists. First thing I need to do is figure out how I'm going to get this hooked up to my capture setup. I did a quick search looking for, well, the pinout of the RGB output on here, and I started finding some weird conflicting information. For instance, this says that older machines like this one have composite sync output on green, which confuses non-Acorn monitors. Since it says you can modify the motherboard to remove sync on green, that would imply we should be able to see in the circuit diagram that sync is being mixed with the green signal. Looking at the service manual for this exact machine, it doesn't say anything about sync on green. It just says RGB is pins 1, 2, 3, and it has a C sync, and then these are all ground. And this should be really easy to make a little adapter, but I still want to find out if sync on green is actually happening on this machine, because that can lead to issues where you have like blown out green channel because of all that extra sync information that's confusing the input circuitry. All right, here's what I wanted to see. So there's the video output jack, and it looks like we either have horizontal vertical sync optionally via jumper links or just composite sync. The green pin, though, that doesn't appear to have any sync on it or even the capability of sync. These are the horizontal and vertical sync output drivers, and they do not connect to any of the RGB signals whatsoever. So that post we saw was not correct. And it appears that based on the jumper configurations, pin 5, which oddly enough on the 9-pin connector showed as not connected, it looks like it's either connected to, well, it's always pulled up to 5 volts through a 22K, or it's connected to the sync output. And my assumption is there are ways to, well, you put this link in place and that link in place, and then that will create the composite sync, the default configuration. You leave that off and you get 5 volts on that pin, which potentially on a SCART monitor would switch the RGB input. Otherwise, you install this jumper, and then that becomes the vertical sync output. And I guess you take away that jumper. It's not really clear on here how that works exactly. I'm sure it's explained somewhere else. And then this will become only horizontal sync as opposed to composite sync. Either way, I fully understand now how to wire this up so I can make an adapter cable that goes to my RetroTink, and we'll be able to capture this thing at its native resolution with no issues. So let me go whip that up. I prepared a little RGB adapter. This side plugs into the Acorn. That side plugs into, well, it's the standard pinout of Commodore 1084 monitors. And that's good because I actually have a SCART cable that I made that goes from analog RGB with composite sync down to a regular SCART jack. Now it has no resistors except for the sync input, 460 ohms. And that's because typically the output of the sync signal on various computers is not the composite video input levels that what SCART is looking for on its sync input pin. There's no actual sync input pin on SCART, it's just using composite video as the sync itself. The SCART cable itself is wired up for a 1084 monitor. That's how I kind of do all my cables. And with this plugged in like that and that in the back of the Acorn, theoretically, this should do the trick. And then for powering up the system, I have a step up converter. It used to be a step down converter, but I reversed it inside. So now it's 120 volts in and 240 volts out. It'll need to be a future video where I go and rewire the power supply to operate on 120 volts. Incidentally, floating around inside this computer, I found a little piece of square plastic. I don't know where that came from, so just in case it's used somewhere, I've taped it onto the power supply. Before we plug in the video cable, I'm just gonna power the machine up as it is here. I think we should be good to go, and I'm gonna measure the 5-volt rail off of this Molex connector just to make sure that we're actually getting the correct voltage. This has a 2025 date code on it. That implies this machine was used recently. So I don't think there's any reason to believe that there's anything wrong with this computer. Okay, so I'm gonna apply power to the power supply. I don't know if the power switch on the back is turned on or off, but we'll just keep an eye on this. And I have my finger on a power strip in case anything looks out of the ordinary here. I'll quickly turn it off. Okay, nothing happened. The step up transformer is turned on though now. I see the light on that, so I'm gonna flip the power switch on the power supply. Here we go, 3, 2, 1. Okay, 5.3 volts, certainly a little bit high, isn't it? Let's switch over to the 12-volt rail and just see what that looks like. All right, 12.7, also a little bit high. It could be because this power supply was calibrated to have a hard drive drawing a load, and of course that's not there. 5.3 volts is slightly high, but I think it's probably going to be fine. When I open the power supply to do the mod for the 120 volts, I'll turn down the voltage if there is a potentiometer, which there probably is knowing the older power supply this is from 1988. All right, so let's get this video cable connected. I have the SCART cable hooked up to the 1084 side. We'll get this plugged into the back of the Acorn. We'll be using the RetroTink with firmware 3.71, and let's just make sure the input is set to SCART. It already is. Okay, here we go. I'm crossing my fingers that we actually get a good image. If not, maybe there's something wrong with my cable. But here we go, 3, 2, 1. Okay. It's taking a very long... Ah, come on, really? Okay, so it's not detecting any kind of signal right now. I know I don't have the keyboard connected, but I'm pretty sure you don't actually need the keyboard connected to a machine like this to get it to boot up, right? Let's switch tactics. I was being greedy trying to use RGB because that means the adapter could be bad or my cable's bad or something else. So let's just go for composite video instead. It'll be monochrome, but at least it should work if this computer is actually working. So I'm going to change the input to YPBR SDP because that means that the green input, which is where this cable's connected to, is going to be a high resolution Luma only signal, no color, because that's what this machine is doing on the composite video jack. Okay, let's try this again. 3, 2, 1. Uh-oh. Okay, well, let's just try composite just in case. Oh no, so there's no video output. And just to show that the RetroTink is working or not, I'm going to plug in my test pattern generator. Yes, okay, we have good signal. And I'm going to switch the input to this SDP mode, which should still result in a nice high resolution image. Yes, there it is. Nice and high resolution, monochrome, looking good. But plugged into the back of the Archimedes, we're not getting anything. Okay, let's do a little bit of troubleshooting. I'm probably gonna have to end this video soon, but we'll just unplug the IDE card just in case that was causing some kind of an issue. No, that made no difference whatsoever. Just in case these two outputs are maybe somehow swapped around, we'll try the other one. It's doing something. I wonder if this is stuck in a high resolution mode. And what I mean by high resolution mode, like maybe the NVRAM in this machine is configured for a high resolution monitor, say 31 kilohertz. So the jack on the back that's labeled sync, that's the one we just plugged into. This is outputting a 5-volt TTL sync signal.
This thing seems to be unable to measure that frequency, but judging by the fact we're at 5 milliseconds per division, you can just count how many divisions we have, we're at about 50 hertz, probably 50, 60 hertz, something like that. So that's what's coming out of the sync output. I've switched over to the other video output signal, and we're at 200 millivolts per division, and there's not a lot coming out of that output. Let's power cycle the computer here. Okay, there's something there, and then it went up to like 5 volts and then just went away. Do that again here. That's definitely a video signal that we saw briefly, and then it just disappears. Okay, I'll turn that off because the fan is kind of noisy. This definitely needs a Noctua fan mod. So basically we're not getting the correct sync outputs because we're missing the horizontal sync entirely. And we're also getting weird things on the video signal. And it looks like we have a normal video signal for a little while, and then it goes out of that mode, which implies that maybe there's something with the NVRAM on this machine that is setting it into a weird video mode that's just somehow not compatible. So I'm going to spend a moment to try to figure out if there's like a reset procedure just to kind of reset this thing back to factory defaults, and maybe that will cause this to sort of come to life. Right, according to the service manual, you can clear the CMOS RAM by holding down the delete key, not the backspace key, but the delete key when you power up the computer. And I have the composite video connected back up to the correct mono output, not the sync output. And I'm going to hold the delete key, not the backspace key, and power on the computer. Here we go, 3, 2, 1. Well, something happened there, obviously. You should see a red border around the screen to confirm the delete power-up is taking place. This action clears the CMOS RAM and resets configuration defaults to the original specification. I swear I heard a faint beep out of the speaker, like just a slight tone. So I'm going to do that thing again where I hold the delete key down just to kind of do a full factory reset. There we go, we're like seeing something here. And then I heard the beep come out of the speaker. Let's go back to SCART RGB. Wait a second, wait, it's just suddenly working. I don't, why wasn't it working out of the composite video jack? That is confusing to me, very confusing. Whoa, we're up and running. Let's try doing that factory default again. Remember, I don't have the hard drive even connected up, so I'm holding the delete key on the keyboard. And I assume, oh, there's a flashing cursor. Oh, RiscOS. There it is, RiscOS 3, 1992. We're up and running. Cool, so my adapter cable for the SCART cable, that did work the whole time. And it was just stuck in some strange mode. And I don't really get why the monochrome output doesn't work, but maybe there's some other configuration option you have to set to make that standard composite video. Okay, well, I think what I need to do now is let's just put this IDE card back in. Not that it will necessarily work without potentially some kind of configuration. Okay, the mouse is connected, and I'm using my Microsoft optical mouse instead of that sticky Kensington one. Computer turned on and the mouse lit up, so that's got power at least. Okay, and it's working. Wow, okay, so my first time in RiscOS 3, do I know what I'm doing in RiscOS? No, I don't. How do I even move a window? Is that normal? Okay, that's normal, you just click and drag. So what we're looking at here is entirely based in the ROM. Definitely doesn't seem to be using this IDE card at all. It probably had a configuration set, and then I potentially could get that working. And I'm assuming there's a bunch of programs and games and stuff on here. Looks like we have memory allocation settings. Let's speed this up. This was way too slow for the mouse. Okay, so this is the sound settings. I was hearing sound in sound settings, and now I'm not. So there might be a problem with the speaker because I had it on, it was set to quiet beep, and now I set it to loud. I heard something, and then it just stopped making sound. But it seems to have various digital sounds here to here, and we're not hearing those anymore. They stopped working. Right, here's the monitor type selection. It does say automatic. Maybe we just need to set that to normal, not VGA, Super VGA, multi-scan, high-res mono, or LCD, interesting. Fonts, anti-aliasing, subpixel anti-aliasing, that sounds kind of fancy. We got window manager stuff, interactive file copying, instant dragging. Oh, nice, so you can turn that off. So I guess if you want, yep, the outline dragging for higher performance.
Allow windows off screen. Ah, that's something you cannot do on the Amiga. So I suppose if we turn this off, then the windows are stuck, yep, on the main screen, just like on the Amiga. Okay, I realize here, if you push the middle button, which is the scroll wheel, then you actually get a little pop-up menu. Back in the mouse area here, there's something really weird about the way the mouse pointer moves on RiscOS. So when I move the mouse really slowly, like I'm doing right now, the pointer doesn't move at all. Let me put the mouse pad on here. Okay, see if I'm moving the mouse pointer moves, but watch, I'm gonna move the mouse slowly, and it's like barely moving. So it's very hard to feel precise, like if you're trying to hit a target, especially when I was on the fast mode. Like it has a very strange acceleration curve that doesn't, well, I'm not used to it. It doesn't really feel natural. And what about the Acorn logo here? Ah, task display. All right, we can definitely see this has 4 megs of RAM. I mean, I can't see that exactly, but we have more than 2 megs because it is adding up to more. Yeah, there we go. Total 4096K. Awesome. This is a perfect stopping point for this video. Otherwise, it could go on for way too long. This is a whole new world for me, this computer. And I think it's gonna take me a while just to wrap my head around it. Not to mention, people watching this video are probably gonna know a lot more about it than me. And I'm sure there'll be tons and tons of great comments suggesting software I try or things I need to do on this that I didn't do properly and other useful tips and tricks. Stuff that is definitely outstanding right now is power supply needs to be converted to 120 volts. I need to fix the audio, so whatever's wrong either with the speaker or the audio circuitry, that needs to be investigated. As I said, I heard it beeping, which is very, very quiet. So maybe there's a bad trace or a bad cap or something on the board, or the speaker has just gone bad. Also, the IDE adapter is not seemingly working. I mean, it maybe works, but it's just saying bad drive. There's probably a configuration thing that I need to do there. Since this is a name brand card, not some kind of homebrew thing, I need to go look up the documentation for this card. Probably tells me exactly how to get that working. And then after that, when all that's sorted, there is so much more to try and learn about this computer. Run software, run games, see what it's all about. Yeah, there's just a lot to learn. There's one last thing I'd like to talk about before I end this video. Mike sent me a letter after I told him that I started opening this computer because I had it sitting around in the basement for a few months. And Mike told me that really getting this to me was not just a donation from him, but a community effort from the Acorn community to me. It was mentioned in the original letter from Mike that Sahad, the original owner of this computer, worked with Mike to really get this machine to me. But beyond that, when it comes to the monitor conversion kit that we looked at for the 1084 monitor, it looks like eBay seller Toksicy2k from Australia created that monitor flap door for me. As far as I'm aware, Toksicy2k didn't originally sell that Acorn replacement door. I think they were selling Commodore replacements and other 1084 style replacements. And to create this door with the correct font on it, the Acorn community over on Facebook figured out the correct font to use and got that over to Toksicy2k to have this door made for me. So this came from Australia, and then the Acorn label that goes on the front of the monitor came from Marco over at Retro 8-Bit Shop in the Netherlands, where apparently this sticker was a one-off and it's not even something that's normally sold. So Marco, if you're watching this, perhaps this be something you could sell to the community, because there might be other Acorn enthusiasts who want to kind of recreate their Archimedes setup, and if they have a Commodore 1084 monitor, they can do the conversion using Toksicy2k's front door and your sticker to really turn it into like a correct looking Acorn monitor again. And then apparently Mike is the one who created the box that created that conversion kit from color to color with the U, and I thought that was pretty funny. And the last thing Mike added to this letter was basically, why Archimedes? Well, Mike says it's simply one of the most important computers ever made. It's the grandfather of every mobile device we use every day, and it's really not celebrated enough in my opinion. Well said, well said. I might have to argue, though, that perhaps the most influential computer ever made was the IBM PC, and that was simply because it resulted in IBM PC clones, and the proliferation of those clones enabled the masses to get into computers. But that is definitely a debate for the comments section, because clearly the ARM processor that's in this evolved into all the billions and billions, but perhaps trillions of ARM cores that exist in every device. I wouldn't be surprised if like even this thing runs an ARM core inside of it. Just everything. Yeah, this remote, my watch, it just goes on and on, right? What's actually running an ARM core? And yes, it all does stem back to Sophie Wilson and the other engineers at Acorn coming up with those early designs. It's completely mind-blowing. It's completely mind-blowing and kind of hard to even comprehend the influence. So I am so excited to finally have an Acorn Archimedes computer, a working one.
And I guess there's a lot for me to learn, so I will be reading the comment section and checking out people's advice, because I'm sure there's tons and tons and tons of things that I've missed, and I'm gonna need all the help I can get. So definitely comment down below. And I guess that's gonna be that. So thank you to Mike and everyone else who made all of this possible to get this to me here in the basement. And I'm really looking forward to playing around with this some more. Thumbs up if you liked this video, thumbs down if you didn't, and I guess that's gonna be that. So stay healthy, stay safe. I'll see you next time. Bye-bye. All right, hello everyone, welcome back. Oh my God.